pretty good. You got halfway.
Welcome back, everybody.
Yeah.
All right, so I'll just start from question 1, and then we'll keep going. Does that sound good?
Mm-hmm.
Because again, there's 26 questions on the review. Again, I'm not going to be asking you all 26 of these questions.
Okay. You're going to be asking us more?
No, less, definitely less, because there's a lot of A, B, C, D. If you notice, these are probably ripped either straight off of actual tests or the reviews. I didn't really change problems. These are just I basically just took all the files for the reviews or the test and compiled them all into one.
Is that also what the test is?
What the exam is? Yeah, very similar to that.
Okay.
I did not keep exact same questions. I did change some of the wordings and stuff, but it's all very, very similar in terms of content. All right, and again, you do get your yellow packets too. With the data from the chart below, that would be mean if I just asked you not, no formula sheets, cold turkey on the exam. With the data from the chart below or to the right, find the relative and cumulative frequencies for each class. Remember, relative frequency is the percentage frequency. Cumulative frequency is the built-up frequency. So, for example, here this is 4, this is 12, this is 22, this is 28, this is 30, so 31. Right. Just double check that. We got 22, 28, 31. Good, yeah. So there's our cumulative frequency. Remember, the cumulative frequency for the last class should equal n. And then we take relative frequency by finding the percentage of each one. So in this case, I'm going to take 4 out of 31, 8 out of 31, 10 out of 31, 6 out of 31.
You can use with the fraction on the test. You let us do that last
Did I
time.
last you? Yeah, I guess that'd be fine. Yeah, so I'll do the same thing. 4 out of 31, 8 out of 31, 10 out of 31, 6 out of 31, 2 out of 31, and 1 out of 31. Right. Relative to the total. Pretty simple, right?
Yeah.
Number 2, your grades in English along with weights are as follows. Find your final score in the course. The weighted mean, right? The weighted mean. I'm going to get out my yellow sheet. Way back in chapter 2, we talked about weighted mean being x bar is sum of x's divided by sum of w's. Right? Sum of x's times the sum of w's. Oh, sorry, xw's. Sum of xw times the sum of w's. So I'm going to do xw over here because I don't have room on the other side. And what I mean by xw is the score times the weight. Right? Score times the weight. Now, in this case, what is the sum of w? 100 or 1, right? It all kind of depends on what you choose your w to be. If you choose your w to be a decimal, then you would say, the sum of your w's is 1. If you choose it to be the percentage, and you just say sum of w's is 100. So I'll just use sum of w as a 1, so I don't have to divide by anything. So that means I'm going to take that weight as 0.05. So 0.05 times 75 is 3.75. 0.2 times 95. 20% is 19. 0.25 times 87. Oops, 87, 78. Oh, that's 84. 0.25 times 87 is 21.75. 0.2 times 90, that's 18. And 0.3 times 92. 27.6. So I'm going to add all these up, and that's going to actually give me my weighted mean. 3.75, 19, 21.75, 18, and 27.6. All said and done, I got a 90.1. Good there? All right, let's take a look at number 3. Draw an example that is symmetric, skewed left, skewed right, place and label the mean, median, and mode. All right, so let's put symmetric in the middle. Let's go skew left over here and go skew right over here. Now symmetric, obviously, right here, right? Where mean, median, and mode are, mode is all in the center, right? Now, skewed left, that means that there is data pulling my mean to the left, right? So that means the tail is on the left. So alternately, that's skewed right. Now remember, what's being pulled by the outliers? The mean is getting pulled the most, right? And then here's my median, and then here is my mode, right? So that means my mean is getting pulled skewed right over here. My median, and my median is here, and then my mode again would obviously be at the top. Good there for number 3? Let's take a look at number 4. Draw an example of a data. Oh, that's still 3. Number 4. Excuse me. The lifespans of species of fruit fly have a bell-shaped distribution with a mean of 33 days and a standard deviation of 4 days. The lifespans of 3 randomly selected fruit flies are 34, 30, and 42 days. Determine their z-scores. Okay, let's take a look at 30. Remember, z-score is equal to, where's it at here? X minus mu over sigma, right? X minus mu over sigma. So mu is 33. Sigma is 4, right? So if I want to calculate the z-score, again, z-score, just off the yellow sheet, is x minus mu over sigma. Okay, so 30, that's 30 minus 33 over 4, so negative 3/4, right? So negative 0.75. Let's take a look at 34. Oh, I forgot 34. Hold on. Guess I'm going in order. 34. 34 minus 33 over 4. So that's 1/4, or 0.25. Those scores are not unusual, right? It's below 1 standard deviation. 42, rather. Okay, so that would be 9/4, which is 2.25. Now that would be unusual, right? Anything above or below 2 standard deviations away from the mean would be considered unusual. Using the empirical rule, what percentage of fruit flies would lie between 29 and 41 days? Okay, between 29 and 41 days. Think about that. How far away from the mean is 29 days? 1 standard deviation. How far above the mean is 41?
1 standard deviation.
2 standard deviations. Because my mean is 33, right? So plus 4 would be 2 standard deviations. That means I want to figure out what percentage is, here's mu, is 2 standard deviations away here, but 1 standard deviation away in the low end, right? So I want to figure out my area under the curve there. Okay, there's a lot of different ways to think about it. Again, they give the empirical rule 68, 95, 99.7. So I know that, how do I want to think about this? That's 34, right?
Yeah.
That's 34. That red piece is 34%, because that's half of 68. Let's figure out the other half of the 2 standard deviations, right? Just looking at this side. Because if that were symmetrical on each side, 2 standard deviations away from the mean on top and bottom would be 95% of the data, right? So likewise, just like I did with that 34, I'm going to cut 95 in half. I'm going to get 47 and a half. And that is the area under the curve on the right side. So this piece in here is 47 and a half. So if I want to add those together, that's going to be my total area under the curve. 34 plus 47 and a half is 81 and a half. 81.5%. Now, what is that? Did I answer my question? Determine using what percentage of fruit fly? 81.5% of fruit flies would live between 29 and 41 days. Okay, and lastly, if I sampled 250 fruit flies, how many of them would you expect to live more than 25 days? Now, more than 25. Think about that. Ooh, that's a kind of skewed, but you get the idea. 25 is down here, right? Here's my mean of 33. How many standard deviations away from the mean is that? 2 standard deviations on the low end, right? But remember that I want, how many am I expecting to live more than 25 days? Not within 2 standard deviations away from the mean, but all of that over there. So am I just going to take 95% times 350 or 250, excuse me? No, I can't do that. I've got to figure out what this is. This is 95%, 2 standard deviations away from the mean, but I've got to tack on this little piece in here. It's a very small amount, but I still have to calculate it in. So if this is 95%, 2 standard deviations top and bottom, that means 5% is left over top end, bottom end, right? So this piece in here is 2.5%, right? It's the outside of the 95%, 2 standard deviations. So all said and done, I want 97.5% of those 250. So I take 0.975 times 250, and I know that's 243.75. Approximately 243.75 fruit flies should last more. 243.75 of my 250. I know if that did not come out to be true, then something must have happened. Number 5. A survey was conducted. The results are shown. If 4 students are chosen at random, without place, what's the probability that 2 like blue and 2 like yellow? 2 like blue and like yellow. Actually, yeah, that's true. What is probability that 2 like blue and yellow? If 4 students are chosen at random, I would assume that I am asking 2 like blue and then 2 like yellow, right? Yeah. The wording is a little weird. What's the probability that 2 like blue? Well, I guess what's the probability that 1 like blue?
137. Oh, just out of everyone.
37.
Yeah, 37, 178.
37 out of 178, right?
Thanks.
Okay. What's the probability of getting the second person liking blue?
36.
Out of 177, right? What's the probability of 1 liking yellow?
51.
We've already taken 2 students out, right?
Oh, 175. 6, 7, 8, 9.
And then we got 50 out of 175. Does that make sense?
Yeah.
So 37 times 36 times 51 times 50 divided by 178 times 177 times 176 times 175, which is coincidentally enough 178C4. But remember permutations,
Oh,
combinations.
right.
So 0.35%. That's probably getting exactly 2 that like yellow and exactly 2 that like blue. Given that a woman is chosen, What is the probability that she likes red or green? Okay, so how many women total?
82.
82, right? What's the probability that red or green?
6 plus 27.
So 27 total out of my 82. 27 over 82. Could we go through and use like the or probably? Sure. But if it's presented in a table like this, just count that. It's the easiest way to do it. If 3 students are chosen at random without replacement, what is the probability that at least one of them is like, ooh, these are weird ones, right? At least one likes red. Right? One likes red. Okay, if I want the probability that at least one likes red, isn't that the probability of 1 minus the probability of none, right? 1 minus none. What is none red? What's the probability of getting a person that does not like red? None red, right? So, and I don't care about men or women, right? It's just, so I've got to add up all these out of 178, right? What's that, 161? 161 out of 178. But that's 1, right? Let's go with 3. Follow me? That's 3 of them. So 161 times 160 times 159 divided by 178 times 177 times 176. Okay, so I want to take 1 minus that. 1 minus, so the answer 26.1%. Questions about that? Okay, looking for independent and dependent. Now, this is interestingly enough, kind of similar to what we did with this O minus E over E thing. But we're not running a hypothesis test. We're just using the conditional probabilities. Because if I'm truly looking at if these events are independent, I am going to say, okay, the probability of man, if these events are independent, would be the same as the probability of man given orange, right? One should not affect the probability of the other. The probability of man should be the same as probability of man given orange. And I could likewise say this. If I wanted to do it the other way around, I could say the probability of orange should be the same as the probability of orange given that it was a man. Because that should not affect the probability. The probability of man should not affect the probability of orange. Okay, so let's do it with this first one. What's the probability of man? 96? 96 over 178. Let's see if that's equivalent to man given orange. Okay, what's the probability of man given orange? 30 out of 37. Let's see what those decimals come out to be. 96 over 178. 0.539. 30 out of 37. Definitely not 0.539. 0.81. So this is not true. So therefore, what do I say about these events? They're dependent. They're dependent. This stuff is a throwback, man. Go on. This is good stuff. Okay, let's take a look at number 6. In a survey of Lake High School seniors, 90% of the students said they, remember these questions? Smartphone, dumb phone questions?
Yeah.
90% said they had a smartphone, 3% had a dumb phone, 7% didn't own a phone at all. I think that's more likely to happen. Like, not owning a phone at all rather than owning a dumb phone. You know what I mean? Of those students who owned a smartphone, 60% owned an Apple. If you were to pick any one of the seniors at a random, what is the probability that you select smartphone made by Apple? Okay, so basically I'm asking this. What's the probability of S and A? Right? Smartphone that is also Apple. That's what I really want to know. Okay. And probability. Probability of A and B is the probability of A times the probability, I'm putting in B and A. The probability of S times the probability of S. Oh, I got that other way around. Oops. So I'm trying to transfer from A's and B's to S's and A's. It's really messing me up. A given S. Do I have all of those things? Yeah, what's the probability of a smartphone? What's the probability of an Apple given that it was a smartphone? Of those students who owned a smartphone, 60% own Apple. So 0.54. It's the probability that your selection owns a smartphone. All right, 6-sided die is rolled. Get some probability. You roll the die 4 times. What is the probability that you roll an even number every single time? Okay, it's probability rolling a even number on the first try. 1/2, right? What about the second try?
1/2.
Third?
1/2.
4. 1/16? Yeah, whatever that decimal is. If you roll the die 3 times, what's the probability that you never roll a 1 or a 2? Okay. What's the probability of rolling not a 1 and a 2? 1 or a 2 on the first roll?
1/2.
No.
Wait.
Yeah.
2/3. 2/3, right?
Yeah.
Does that change each roll? No. So it's 2 to the third over 3 to the third, or 8 over 27, or whatever that decimal is. Because I have 4 successes each time. 4 out of 6 successes. That's why it's 2/3. Number 8. You're purchasing a new phone and you have 4 different models. Oh yeah, these are 4 different models, 5 different colors, 2 different storage capacities. What do I do with those values? Multiply them all together. That's a fundamental counting principle. 4 times 5 times 2, that's 40 different ways you could have that smartphone. How many options? 40 different options.
You could draw them all out.
I could, yeah. Yeah, you can make a big tree diagram if you'd like to. You can, if you got extra, Okay, when you charge your computer in the student center, you have to create a PIN number to lock your computer. PIN numbers have 4 digits, choosing from 0 to 9. How many? Did I do like an even number thing? Odd number thing? No. Remember we had that whole discussion of 0 is even or odd.
Yeah.
I get those out of there. I get the weird ones.
Zero's even.
Okay, how many different PIN numbers are possible if numbers cannot be repeated? Okay, I've got 4 digits, right? How many different options do I have on my first digit? If I go from 0 to 9?
9, 10.
10. Right, it's going from 0 to 9.
0 counts as
How many different options do I have on the second?
9,
9. Then,
8,
then,
7, 7.
7. So it's 10 times 9 times 8 times 7,
10C.
which is actually 10C.
What?
Oh no, sorry, 10P4. Because order matters, right?
Yeah.
If I change the order of the numbers, it creates a different passcode, right? So 10, P4. We hadn't learned that at that time, but that's truly what that is. 5040. The first number has to be a 1 or a 2, and the fourth number must be odd. Okay, so my first digit has to be a 1 or a 2. Okay, so there's only 2 options that it could be, right? Are there any stipulations on the second and third?
So 9 and 8. Oh, 10.
The 4
Yeah.
must be odd.
Because I'm not making the stipulation that numbers can't be repeated. Now, and the fourth number must be odd. Okay, so what are my odd numbers? 1, 3, 5, 7, 9. So I have 5 different options there.
1000.
So 2 times 10 times 10 times 5 is 1,000. Excuse me, 1,000. Not 10,000, 1,000. You can never have an even number or a 9.
4.
Now we said,
Are we counting 0?
I know. What did you guys do?
I
I
count
was counting 0.
You count 0? So 0 is an option? Okay, so 0, 1, 3, 5, 7, 9? No. So 5 options. Right? Five to the fourth power is 625.
No.
Isn't it?
It would be 4 options.
Is it 4 options? Wait a second.
Because you can't have 9.
0, 1,
No, and
3,
you
5,
can't have
7.
an Well, you're counting 0 as an odd.
It's really just dependent on if you count 0.
I counted it.
Can you have 0? You can't have an even number. Is 0 even?
I'd say, yeah, probably. But it's
So if you say 0 is even, then you should be 4 times 4 times
Yeah.
4 times 4.
both of them are right.
Right. Honestly, I would accept either answer of 625 or whatever 4 to the fourth is. 64 times 4, 256.
We need to ask the creator of 0 his number is even or odd.
There's a book by Stephen Hawking. It's called God Created the Integers. It's like this. I checked it out in the library one time.
I don't think I'm gonna read that.
All right, let's. You want to make this be our last one?
Sure.
That's cool with me.
I just feel like
I
watching
guess,
watching
you know.
TV is just so much better. Like it's like reading a book. Besides, it's like it's more entertaining pretty much.
It's more time efficient.
And it's more time efficient, more entertaining.
More colors.
It's just like a book but better.
Pictures.
Pretty
Book
much.
was better.
For you, Lord of the Rings.
Yeah.
Is the book better?
The book was definitely longer.
What was better?
It was pretty difficult to read. It's just so slow. Like the first 100 pages was like the first 10 minutes. A standard 52 card deck has 4 suits, 13 value per suit. If you choose one card at random, what is the probability that the card is either a club or a king? Okay, so we are looking at probability of club or king, right? Probability of club or king. Okay, now ors. I got that on here. Where's it? Or. Probability of cork. Probably a club or king. Is the probability of club plus the probability of king. That's a K. Thanks. Minus the probability of club and king. Canned. Okay. So what's the probability of club?
452.
Club. 13 out of 52. Right. What's the probability of king? 4 out of 52. What's the probably a club and king. Oops, that's a minus sign.
One.
And how many clubs that are also kings? 1. So 16 50 seconds, which is 8 26th, which is 4 13th.
330%.
No, that is.
Oh,
Good there?
yeah.
Cool. Yeah, we got through 10 questions.
That's not too shabby.
We're good.
Just gotta get to 26.